Hello geometers and general seekers of truth. In this video we will take a look at medians, okay, and we'll talk about what they mean and what their uses are for and how do we use them. So first let's begin with a basic definition. What is a median? The median of a triangle is if I start out by taking a midpoint, so let's say I find some sort of midpoint here of one of the sides. Okay, let's say that right there is my midpoint, and let's call that M. Now we already know how to find midpoints using a compass and straight edge, so I'm not going to belabor that point. If I take a ruler and I draw a straight line from A to M, now the key is it has to go from the midpoint through the other vertex. So there you have it. If I were to draw a straight line from A to M, that straight line right here, from the midpoint to the vertex, that would be considered a median. So we can say that AM is a median of, let me define this first and then we will use the example. So a median is a segment from the midpoint of a side length through the vertex. Alright, so a segment from the midpoint of a side of a triangle to the vertex of a triangle. So in our example here, we have that AM, segment AM, is the median of triangle ABC. Now, that certainly isn't the only median. We can find other medians by using other side lengths. So if I bisect AC, let's say right about there, okay, and if I were to bisect that, then these two lengths would be congruent. Then I were to draw a straight line segment, let's call this point here N, from this line segment through B, that would give me another median. Alright, so I've drawn in this green line right here from the midpoint N through the vertex, so that's B. So we can say that NB is also a median. And of course you were probably wondering, well, what about the third median? Well, let's just draw that in here too. So I found the midpoint of AB, drew a line from that midpoint through C, and not surprisingly, all three of the median meet at the same point. So let me write some notes here. Let's call this point here N, we have an MP. So we can say CP is also a median of the triangle ABC. So we're talking about triangle ABC here. And the place where they meet, this point here in the middle, we'll call that G. That is the centroid. Okay. So so the centroid is the point where all three medians intersect. Okay, and I realize I did not follow directions very well here. I should not have named this G. I should have followed my own directions down here and named this Q. All right, so Q should be that. Will the centroid always be inside the triangle? Why or why not? Well, if we think about how these medians are constructed, they're always going from a side length to a vertex. Side length to a vertex, side length to a vertex. So those three segments, the blue, the red, and the green here, will always be inside of the triangle. So yes, okay. Because the median, if you look at the picture, the medians are always, entirely inside the triangle. Inside the triangle. So with those ideas in mind, we are going to continue with what's called the Centroid Theorem. And the Centroid Theorem says a couple different things. So the first thing that it says here that really is regarding the median. So what it says is that the median will always divide the triangle into equal size triangles. So in other words, CP will cut the triangle into equal parts. That does not mean congruent, but it does mean the same area. Okay, so the median of a triangle divides the triangle into two smaller triangles of equal size. And when we say equal size, we really mean area. What I want to emphasize here is we're not saying that they are somehow congruent. They may or may not be congruent, but they will be the same area. Okay, so may or may not be congruent. Okay, so it would be silly to think that they actually are congruent all of the time. So they are only congruent sometimes. Okay, so that's the first part of the centroid theorem. That's relating to the median. The second part relates to the size and proportions of a median. Okay. So I'll state it this way. From the median to the from the vertex to the centroid. So from the vertex to the centroid is always 2 times the distance from the centroid to the midpoint. So let's illustrate this to get a better sense of what is it exactly that I'm trying to say here. So let's say I have some sort of triangle. Okay. And just for the sake of simplicity, let's put the centroid in there somewhere in here. And let's name this triangle A, B, C. And let's call the midpoint here M. And let's make ourselves a median of this. So if I were to draw, all right, so let's say I were to draw this picture. Okay, so I have a triangle, midpoint, and the median. And let's say that G is the centroid. So let's make this note, G is the centroid. Okay. Then what this theorem says is from the vertex to the centroid, which means basically from this vertex to the centroid, from A to G, right, is twice the size from G to M. Okay. So what this basically says is that AG is equal to twice the size of GM. And so another way that we could put this, and another way that we could organize this, is to say that AM, so if you go this entire length here, that is 3 times the size of GM. Now let's think about why that is. If GM was, say, like X, then AG would have to be 2X, because that's what this comparison is. So that means AM would have to be 3X. So that would make it 3 times the size of GM. And one more comparison that we can have would be comparing GA or AG to AM. So like the medium length, the yellow length here, to the entire length. So let's what do you think, comparing AG to AM? Well, AM is 3X and AG is 2X. So that means AG is about 2/3 of AM. Excuse me, I shouldn't say about 2/3. It is exactly 2/3. Okay. Or we can also flip it around and say that 3/2 of AG is equal to AM. Okay. So going from here to here, just multiplying both sides by 3/2. So There's a few other ways that we can write this, but these three are probably the quickest and the simplest, or these four rather are the simplest ones to remember. And it comes down to this root equation here, which is that AG from the vertex to the centroid is twice the distance from the centroid to the midpoint. Okay, so that was a little bit lengthy with vocabulary and examples, but we have to build a foundation here before we go on and work on some of the trickier problems. As always, ask for help if you need it. Thank you for watching, and have a wonderful day.